Welcome to Curriculum Course, the game show with only one episode. I'm your host with the most, Binky. I'm very happy to introduce our contestants today as they quickly talk about immunofluorescence. Our first contestant of the day is Sprinkles McMarshmallow. She's from the North Pole. She learned to write from penguins, and she's part elf.
Hi, Merry Christmas, hi!
Our second contestant of the day is Lillian D. Hill, known by her friends as LDH. She is part of Dr. Hayden's advanced biochemistry course at Birmingham Southern College, and her favorite food is bacon.
Happy to be here, Binky.
Our third contestant is Jane Doe. She would not give us a lot of information about herself, so I'm convinced she might be a part of the FBI. Alright, ladies and gents, let's get this show on the road. I'm going to quickly state the rules to this game show. So, it's basically like any other game show. You hit the buzzer, and you get a certain number of points per question, depending on the difficulty of the question. Alright, our first question of the day is worth 10 points. What is an antigen? Sprinkles, you got it. What is an antigen?
An antigen is a toxin or a foreign substance that induces an immune response in the body, such as a production of antibodies.
That is correct, Sprinkles. Sprinkles takes the lead with 10 points. Now on to our next question. What is an antibody? This question is worth 20 points. So what is an antibody?
An antibody is a protein that is produced in response to a specific antigen. It can chemically combine to substances that the body defines as alien, such as viruses and bacteria.
Very good, Jane. Very precise. Jane gets 20 points. All right. Our next question is worth 200,000 points. Our third question. What is immunofluorescence?
We do know the answer. Remember that lecture in immunochemistry that we had that time?
No, I do not remember that lecture.
Okay, well, no, we had a lecture, I promise you.
Mm-hmm.
There was a lecture, yes.
Was it the one that we ate the cinnamon?
Yeah, the one that we had the cinnamon rolls and the coffee before. Yeah, that lecture.
Okay, that was on immunochemistry.
Yes, immunochemistry,
okay.
Yeah, that immunochemistry lecture.
There it is. I remember.
Yeah,
Yes.
immunofluorescence.
Yes, it's whenever we talked about immunochemistry.
Yeah.
Immunochemistry is the use of antibodies and antigens to analyze biological samples.
Yeah, that's
so
right.
we can assume that immunofluorescence is part of immunochemistry.
Yeah, that's right. Yeah, that's right.
That's right. Yeah, I remember.
Yeah, so basically, can detect antigens in a biological sample
And biological samples are either cells or tissues.
by using an antibody.
And this isn't the only way that this can be used. It can also be used to detect proteins, glycans, and small non-biological and biological molecules inside of a sample.
Yeah, and if you recall, there are two different types of immunofluorescence, direct and indirect.
Mm-hmm.
Okay.
So direct immunofluorescence uses a primary antibody to target a specific antigen. The way that this works is that an antigen is bound to a culture of cells or tissues and then is flushed with a buffer that has that specific antibody in the buffer. The antibody then comes in and interacts with the antigen, and the antibody has this thing called a fluorophore on top of the antigen, on top of the antibody. That fluorophore is actually the thing that you can see under the fluorescent microscope whenever you're analyzing your data.
Yeah. So yeah, I definitely remember that. Aren't there like advantages and disadvantages?
Mm-hmm.
Yeah.
So one of the major advantages of this technique is that it's very quick. You only have to wash it one time, so it's not going to take up a lot of time in lab. And then also another one of the advantages is that you're not going to have a lot of cross-reactivity with the primary antibody with any other antibodies in the cell. The disadvantages of direct IF include that it is kind of costly because there are not that many commercially made primary antibodies with this fluorophore on top of it. And because there are not that many commercially made, this also poses for very low flexibility with experiments. Wasn't I over there like 2 seconds ago?
Yeah, I know. It's crazy. Like, who knows? The brain, the way it works, popping around all those little synapses.
Yeah. All right, so what were we thinking about again?
Yeah, direct IF and indirect IF.
Oh yeah, so the second type of immunofluorescence is indirect immunofluorescence.
Yeah, so indirect IF is pretty similar to direct IF. You have your bottom of the cells right here, your culture cells, and you'll have your antigen right here. And then your antibody will connect to it. This is actually your primary antibody. So you can already tell how it kind of looks similar to the direct IF.
Yeah.
And then you'll have your secondary antibodies come in just like this. And these are actually going to be the ones that have the fluorescent tag on them. So these will be the ones that fluoresce under the fluorescent microscope.
Okay, that makes a lot of sense.
Yeah, so you can kind of see how it's similar, except instead of having only a primary antibody, you'll have your secondary antibodies as well.
I'm remembering this one class.
Yeah, makes sense, yeah.
So are there advantages and disadvantages just like there were in direct IF?
Yeah, of course. So just like direct IF, there are also several advantages and several disadvantages. One of the advantages is that indirect IF is much more cheap. That's because there's a lot of different types of secondary antibodies on the market today, and a lot of these different types of antibodies can actually connect to the primary antibody. So a lot more cheap. Also, in addition to that, they are much more flexible.
So the experiments themselves are a lot more flexible.
Yeah, definitely.
And isn't that kind of also because you can have multiple secondary antibodies binding to one single primary antibody, that makes it more sensitive, right?
Yeah, that's exactly right. So especially if you have a very sensitive experiment that you're working on, you can always try to do indirect IF.
Oh, we switched
There's the
again.
switch
There it
again.
is. I don't know how it works.
Yeah, so just like the advantages to indirect IF, there are also several disadvantages.
Such as?
Yeah, so these include, it takes a lot more time to do these experiments.
Okay. That makes more sense because you're using 2 antibodies rather than just 1.
Yeah, so it takes a lot more time just to run these experiments. But who knows? Better time for better results, right? So, and also, in addition to this, we have the fact that it is at greater risk for cross-reactivity. Yeah, so that can include, like sometimes there might be like background fluorescence and things like that.
Yeah, and
because
that
it can react with something else other than the primary antibody.
Well, I feel like we actually know a lot more than I thought we did.
Yeah, I'm proud of us. Who knew that one little lecture could instill so much information in our little brains? Since we are the brain, right?
Yep.
There you go.
Do you think we're ready to answer this question?
Yeah, I think we're ready. Let's do this.
Let's do it! Woo!
All right, LDH, you were first to buzz in, and a little aggressive, might I add, as well. What is immunofluorescence?
Immunofluorescence is a bioanalytical technique that is used to quantify the amount of antigens that are in a sample by the use of antibodies. There are 2 types of immunofluorescence, direct and indirect. Direct uses 1 single primary antibody, and then indirect uses 2 antibodies, a primary and a secondary antibody. The indirect immunofluorescence is significantly better than the direct immunofluorescence. The advantages highly outweigh the disadvantages of that specific technique. The advantages being, or the disadvantages being, that there is an increased risk of cross-reactivity between both antibodies, and it also takes a little bit more time. However, the advantages are that it costs less, it's more sensitive, and then you also get a little bit more flexibility with the experiments that you get to run. So overall, in my opinion, indirect IF is the way to go.
That is correct! LDH wins it all!
Oh yeah! We won! We won!
Yeah. Who knew that we would have won this thing? We didn't even really describe some of the practical uses of it.
No, I'm actually kind of surprised, but do you remember those academic journals that we found?
Oh yeah, it's not like we don't know. Yeah. Don't you remember those journals that they were talking about how IF can be determined to help in lupus cases, also in some multiple sclerosis cases.
And it's also been used to kind of detect more on the research side of Ebola and the Rift Valley fever virus.
Yeah, that will definitely come in handy, especially when we have finals coming up.
Yeah, we actually kind of do need to go to the library.
Oh.
As fun as that was, it's like winning this Pop-Tart and those Panther bugs. We kind of got that.
Yeah, all right. Let's go study. All right, bye.